Chapter 9, Electrolyte Solutions, Section 9.2, Thermodynamics of Dissolution of Salt in Water. We'll look at the dissolution of sodium chloride in water as an example. After we dissolve sodium chloride in water, ions are formed. We have sodium cations and chloride anions solvated by water molecules. For example, over here we're showing one sodium cation surrounded by several water molecules. And if we look at these water molecules, they have the oxygen pointing towards sodium plus because the oxygen atoms in water bear partial negative charge. They are attracted to sodium plus. Each chloride ion is also surrounded by water molecules, but the difference is this. In those solvating water molecules, the hydrogen atoms bear partial positive charge. Therefore, they are pointing toward the chloride anion in the sodium chloride aqueous solution. Now let's look at the enthalpy of solvation of sodium chloride or table salt in water. Because enthalpy is a state function, we can use the Hess's law to compute the enthalpy of solvation of table salt in water by summing up the enthalpy changes of the following 8 steps. Step number 1. We can decompose this table salt into sodium and chlorine gas. Both are elements, and in this step enthalpy increases. Step 2. We can sublime element sodium in the solid state to the gas phase sodium atoms. In this step, enthalpy increases. And then we can remove an electron from a sodium atom in the gas phase to form sodium cation in the gas phase plus an electron. So over here, this is the first ionization energy of sodium. And then we can actually decompose the chlorine molecules into chlorine atoms. Over here, since we need to break chlorine-chlorine chemical bond, enthalpy increases. And then we're looking at the electron affinity of the chlorine atom. A chlorine atom in the gas phase can get an electron and form chloride in the gas phase. And in this step, enthalpy decreases. Step number 6, water molecules need to make space to accommodate sodium plus and chlorine minus. When water molecules make space or cavities, well, we have to break some hydrogen bonds, and therefore enthalpy increases in this step. Step number 7, this sodium plus in the gas phase now is solvated, and we just put this into the corresponding cavities. In this step, enthalpy decreases due to the attraction between this sodium plus and the surrounding water molecules. Also, the chlorine minus in the gas phase can be solvated as well, and also enthalpy decreases because of the attraction between this chloride ion and the surrounding water molecules. Overall, the dissolution of most salts are endothermic. Therefore, the solubility of a salt is often enhanced at a higher temperature. This statement results from the Le Chatelier principle. Again, the dissolution of salt is often endothermic, and therefore the solubility of salt often increases as temperature increases. There are some exceptions. So mostly you can see this is sodium chloride. Its solubility increases as the temperature increases. And over here you can see there's another salt and another one. They usually have a higher solubility at a higher temperature. But in this same graph, there are 2 exceptions. One is sodium sulfate. The other one is cerium sulfate. So let's look at sodium sulfate. So sodium sulfate is this curve. It's going up, going up. Over here it's roughly 32 degrees Celsius, and then it almost levels off. So usually when you see this kind of behavior, it's because of some change in the chemical property of the chemical. In this case, it's likely due to the changes of the water in the crystalline structure. Alright, so right here. And also there's another exception, cerium sulfate. You can see the solubility of cerium sulfate decreases as the temperature goes up. Why is that? Very likely, I think the dissolution of cerium sulfate is a exothermic reaction instead of endothermic. So right here. And again, why it's exothermic? So if we go back to the enthalpy change of the dissolution of salt, it's fairly complicated. You can sum up the enthalpy change of all these 8 steps. Alright, so it is possible that for some salt, the dissolution involves the enthalpy decrease, and that is exothermic under constant pressure condition.